In parallel computing, the communication time during the exchange of data affects the execution time of the program. That is why the communication process greatly influences the efficiency of parallel program. One of the basic communication process is all-to-all broadcast and reduction. In all-to-all broadcast, all nodes initiate a broadcast. In every process, an M-word message is sent to every other process. A different message may be broadcasted but in a different process. On the other hand, the dual of this broadcast is all-to-all reduction, wherein every node is its destination. It performs the process of one-to-all broadcast simultaneously and may take up to the same process times as one-to-all broadcast.
One of the all-to-all broadcast operations is the linear and array ring algorithm. In linear array and ring algorithm, each node will send the data it has to broadcast to its neighbor. As you can observe in this figure, there are 7 nodes wherein the algorithm of linear array and ring and all-to-all broadcast will be executed.
If you can notice the rectangle, it contains a message of certain node. Each step involved a message of size m takes time.
TS plus TW times M. All-to-all broadcast involves P-1 steps of communication between nearest neighbors.
Therefore, the time taken by the entire operation is T equals open and close TS plus TWM open and close P minus 1.
As the operation proceeds, it is seen that a particular node receives a message from its previous neighbor node. Then, at the end of the operations, all of the nodes will contain all of the nodes' messages.
All-to-all reduction can be performed by reversing the direction and the sequence of the messages. As you can observe in this figure, there are 7 nodes wherein the algorithm of linear array and ring in all-to-all reduction will be executed. The only difference is that when receiving the message from the neighbor node, the receiver node must combine the message to the local copy of message with the same destination before forwarding the combined message to the next node.
One of the all-to-all broadcast and reduction process is the 2D mesh algorithm. In the 2D mesh topology, the nodes are in rows and columns. The all-to-all broadcast here is based on the linear array algorithm as it treats the rows and columns as linear arrays. There are 2 phases in communication in this algorithm. The first phase takes care of the data exchange in rows, just like in the linear array algorithm. All of the nodes collect the message of their neighbor node by row. The first phase of square root of p simultaneous all-to-all broadcast concludes in time ts plus tw times message times the square root of p minus 1. Next is the second phase, which is like the first one, but column-wise. The number of nodes participating in each all-to-all broadcast in the second phase is also square root of p, but the size of each message is now m square root of p. At the end of all the process, each node will contain data that are originally located on different nodes. To get the execution time of this algorithm, the formula is Ts plus Tw times m square root of p times square root of p minus 1. Another algorithm in the all-to-all broadcast process is the hypercube.
The hypercube algorithm for all-to-all broadcast is an extension of the mesh algorithm to log p dimension. Communication takes place along a different dimension of feed node, hypercube in each step. In every step, pairs of nodes exchange their data and double the size of the message to be transmitted in the next step by combining the received message with their recurrent data. Just like the other algorithms, all-to-all reduction can be derived by reversing the order of direction of messages in all-to-all broadcast. However, in Hypercube, instead of concatenating the messages, the reduction operation needs to select the appropriate subset of the buffer to send out and accumulate received messages in iteration. The size of each message exchanged in the ith of the log p steps is 2i minus 1m. It takes a pair of nodes time ts plus 2i minus 1 twm to send and receive messages from each other during the ith step.
That wraps up our discussion in the all-to-all broadcast and reduction operation.